What is Solana? Solana is a highly functional open source project that implements a new, permissionless, high-speed, Layer 1 blockchain. Created in 2017 by Anatoly Yakovyenko, a former Qualcomm executive, Solana aims to scale performance beyond what popular blockchains typically achieve while keeping costs low. Solana implements an innovative hybrid consensus model that combines a unique proof of history, POH, algorithm with the lightning-fast synchronization engine, which is a version of proof of stake, POS. Thanks to this, the Solana network can theoretically process more than 710,000 transactions per second, TPS, without the need for scaling solutions. Solana's third-generation blockchain architecture is designed to facilitate smart contracts and the creation of decentralized applications, DApp. The project supports a number of decentralized finance platforms, DeFi, as well as non-fungible token, NFT, markets. The Solana blockchain was implemented during the initial coin offering, ICO, boom of 2017. The project's internal testnet was launched in 2018, followed by multiple phases of the testnet leading to the eventual official launch of the main network in 2020. What makes Solana unique? Solana's ambitious design aims to solve the blockchain trilemma, a concept proposed by Ethereum creator Vitalik Buterin in his own way. This trilemma describes a set of three major challenges developers face when building blockchains: decentralization, security, and scalability. The conventional wisdom is that blockchains are built in such a way that they force developers to sacrifice one of the aspects in favor of the other two, as they can only provide two of the three benefits at any given time. Solana's blockchain platform has proposed a hybrid consensus mechanism that compromises decentralization to maximize speed. The innovative combination of POS and POH makes Solana unique in the blockchain industry. Generally, blockchains have higher scalability, depending on the number of transactions per second they can support, as more and better they scale. However, in decentralized blockchains, timing discrepancies and higher throughput slow them down, meaning that more nodes verifying transactions and timestamps require more time. Simply put, Solana's design solves this problem by having a leader node elected based on the POS mechanism that sequences messages between nodes. In this way, the Solana network benefits, reducing the workload, which results in higher throughput even without a centralized and accurate time source. In addition, Solana creates a transaction chain by hashing the output of one transaction and using it as input to the next. This transaction history gives Solana's main consensus mechanism its name, POH, a concept that allows for greater scalability of the protocol, which, in turn, enhances usability. How does Solana work? The core component of the Solana protocol is the proof of history, a sequence of calculations that provides a digital record confirming that an event has occurred on the network at any point in time. It can be presented as a cryptographic clock that gives a timestamp to every transaction on the network, along with a data structure that can be a simple addition to it. POH is based on POS using the Tower Byzantine fault tolerance, BFT, algorithm, an optimized version of the practical Byzantine fault tolerance, PBFT, protocol. Solana uses it to reach consensus. Tower's BFT keeps the network secure and up and running and acts as an additional tool to validate transactions. In addition, the POH can be thought of as a high-frequency verifiable delay function, VDF, a triple function, configuration, evaluation, verification, to produce a single, reliable output. The VDF maintains order in the network by demonstrating that block producers have waited long enough for the network to move forward. Solana uses a secure 256-bit hash algorithm, SHA-256, a set of proprietary cryptographic functions that produce a 256-bit value. The network periodically samples the SHA-256 number in hashes, providing real-time data based on the set of hashes included in the central processing units. Solana validators can use this sequence of hashes to record a specific piece of data that was created prior to the generation of a specific hash index. The transaction timestamp is created after this specific piece of data is inserted. To achieve the claimed TPS and block creation time figures, all nodes in the network must have cryptographic clocks to keep track of events instead of waiting for other validators to verify transactions. The Solana, SOL, token. The Solana cryptocurrency is SOL. It is Solana's native and utility token that provides a means of transferring value as well as blockchain security through staking. SOL was launched in March 2020 and has been striving to become one of the top 10 cryptocurrencies entering the space according to total market capitalization. The operating scheme of SOL tokens is similar to that used in the Ethereum blockchain. Although they function in a similar way, Solana token holders stack the token to validate transactions through the POS consensus mechanism. In addition, the Solana token is used to receive rewards and pay transaction fees, while Sol allows users to participate in governance. Answering the question of how many Solana coins there will be more than 500 million released tokens in circulation, and the current total supply of Solana exceeds 511 million tokens, with the circulating supply of Solana being just over half. About 60% of Sol tokens are controlled by Solana's founders and the Solana Foundation, with only 38% reserved for the community. Sol tokens have been listed on most exchanges. The main cryptocurrency exchanges for Solana trading are Binance, Coinbase, KuCoin, Huobi, FTX, among others. Solana versus Ethereum. Solana has received much praise for its speed and performance and has even been cited as a legitimate competitor to cryptocurrency industry leaders like Ethereum. So how does Solana differ from Ethereum, and can it be considered a potential Ethereum killer? In terms of processing speed, Solana is capable of challenging the dominant smart contract platform, as it is supposedly capable of reaching a speed of over 50,000 TPS. Solana uses different consensus algorithms to avoid slow transaction confirmation. This feature makes Solana one of the fastest blockchains in the industry to compete with other industries outside the cryptocurrency space. Compared to this huge number, Ethereum's current poorly scalable proof-of-work model can only handle 15 TPS. Therefore, Solana is thousands of times faster than Ethereum. Another advantage of Solana is the extreme cost-effectiveness of the network, as the project implements new tokenomics for lower fees. In addition, it is worth noting that Solana's blockchain, although it implements one of the POS variants, is more environmentally friendly and sustainable. This is in contrast to Ethereum, whose current POW model requires the use of enormous computing power. However, everyone in the cryptocurrency community is waiting for Ethereum's upgrade to POS. A new type of Ethereum, which is being diligently developed, will consist of an execution layer, formerly known as Ethereum 1.0, and a consensus layer, formerly Ethereum 2.0. It could greatly increase performance, improve scalability, reduce transaction fees, and stop unsustainable energy consumption.